Okay, my friends, welcome to Video Physics. In this video physics, we're going to focus on potential and kinetic energy. We've introduced energy in the class so far, and we've talked a lot about work, and now we've talked about different forms of energy. But in this video, we're going to focus on maybe two of the most important kinds of energy, potential and kinetic energy. I'm going to work a few practice problems, and then I'll have your video physics assignment for you at the end. So I hope that it goes well. If I were you, I'd take out a paper and pencil and go through these example problems as I work them, and then the video physics assignments should be easy, I hope. So we'll see how it goes. Let's get into it. So potential energy is stored energy. This is energy that has the ability to do something maybe in the future, but as of right now, it's just stored energy. An example of this, so potential is stored energy. An example of this would be, let's say maybe you are just holding, I don't know, maybe you're holding a rock above the ground. So here's the ground. And so right now, since you're just holding the rock, it's not doing anything, but it does have stored energy. And so we say that the rock has potential energy. If we look at the other type of energy we're going to be talking about in this video, it's kinetic energy. If we look at its definition, kinetic energy is the energy of motion. And an example of this, if we're going to use this same diagram, is if you were to let go of the rock, then gravity would start pulling the rock down toward the earth. And we would say that the rock had some sort of velocity, and so it would have motion. And in that instance, the rock would have kinetic energy. So again, stored energy, or just holding it here, that would be potential energy. But if you let it go, then it would be converted into kinetic energy. And so hopefully that makes sense. That's an easy example to kind of go through. We're going to get into some more, we're going to work a few problems here. But before we do that, I want to look at potential energy and its definition a little bit deeper. In this video, we're really going to be focusing on a type of potential energy called gravitational potential energy. And so let's look at its definition. It is the energy stored in an object that is held at some height above the ground. So it does have to have a height above the ground in order for it to come down and that for that potential energy to be realized. Okay, if we look at the formula for finding gravitational potential energy, we take the object's mass. This mass will be given in kilograms, so the units have to be in kilograms. The acceleration due to gravity, which we've always seen in physics so far as a lowercase g, that will always be 9.8 meters per second squared. And so nothing new there, we've gone through that before. And then we're going to times that by height, and the height has to be given in meters in order for your calculations to work out. And so if we look at that, we can simplify the formula a lot more. Potential energy is equal to the object's mass times g times h. So we're always going to write this down on every problem that we do in this video, and hopefully that you do on your own. Potential energy is equal to mgh. Okay, let's talk a little bit more detail about kinetic energy. Kinetic energy is the energy found in a moving object, and so that's kind of key, and we're going to go through it in this video, is it has to be moving. And let's look at why. The formula for kinetic energy is equal to 1/2 times the object's mass. Again, the mass is given in kilograms, so kg. And then we're going to times it by the velocity of that object squared. And so the velocity is given in meters per second. And then we can't forget about this squared here. We always have to square velocity, and a lot of students will get into trouble because they forget to square that. And so if we look at the formula for kinetic energy, we can condense it down to this. Kinetic energy is equal to 1/2 mv squared. And so throughout the video today, we're going to be going through this formula. And that we'll go over it enough by the time we're done that you really will have it memorized. So let's do a few practice problems and see how it goes. So practice problem number 1, it says you pick up a large rock of 20 kilograms and hold it at a height of 1.5 meters above the ground. Calculate the potential and kinetic energy of the rock. And as always, I think the best place to start is by drawing a picture of this scenario. And so here you are, standing on the ground here, and you're holding out a rock. This rock has, okay, let me go to a different color. This rock has the mass of 20 kilograms, so let's note that. And you're holding it at a height above the ground, so this height is equal to 1.5 meters. All right, and so it says to calculate both the potential and the kinetic energy of the rock. So I'm going to do both of them. I'm going to do potential energy first. And so let's show you how to find potential energy. Let's going back to the formula. Potential energy is equal to mgh, mass times acceleration due to gravity times the height. And so let's just plug in the numbers here and see what we get. The mass of this rock is 20. Okay, so I'm just plugging the mass in right there. G, on Earth, acceleration due to gravity is always 9.8 meters per second squared. I'm not writing the units to save space here, but you should know the units by now. And the height that this rock is at, being held at, is 1.5 meters. And so if you calculate that out, let me grab my calculator. So 20 times 9.8 times 1.5. And I'm finding that the potential energy of that rock is 294. Now let's talk about units. This is an energy value. And like we've gone over in class, the energy is always given in joules. And so let's see, your potential energy would be equal to 294 joules. Now let's do, let's find its kinetic energy because it wanted that as well. So kinetic energy, we'll find that right here. And let's go over the formula again. Kinetic energy is equal to 1/2 the mass times the velocity squared. Okay, now let's plug in the numbers that we know. It's equal to 1/2 the object's mass. In this case, that rock was 20 kilograms. And the velocity, now if you're just holding it here, it says that you're just holding it. So the rock at this point has no velocity. So we have a 0 here, and we're timesing it through. 0 times anything is equal to 0. So this is an easy example. So the kinetic energy of this rock, because it is not moving, is 0 joules. And so if you're just holding the rock there, you're going to have 294 joules of potential energy, and that's it. So hopefully that makes sense. Let's clear this off and go to practice problem number 2. For this one, it says a race car, its mass is 1,500 kilograms, is moving around a track at 80 meters per second. Calculate the potential and kinetic energy of the race car. Okay, let's draw what's happening here. I'm not the greatest at drawing, especially a race car, but okay. Anyway, you get the point here. The race car is traveling on the racetrack. Let's draw in what we know. It's moving at 80 meters per second, and its mass is so m is equal to 1,500 kilograms. Okay, and so now we can have a visual of what's going on. Let's answer the question. It said it wanted us to find both the potential and kinetic energies again. So let's do that. Potential energy first. Again, let's go over the formula. Potential energy is equal to mgh. And so let's plug in the numbers. The mass is 1,500. So I'm going to plug that in right there. G is 9.8. And h, the height. So if this race car is traveling around the track, it's on the ground, so it doesn't have a height, so we can put a 0 in there, and 0 times anything is 0. So potential energy of this race car is 0. Gravitational potential energy, anyway, would be just 0 joules. Okay, and so let's go to kinetic energy, which is the energy of motion. So obviously, hopefully, we can find out what the kinetic energy of this race car is. Let's go over the formula again. Kinetic energy is equal to 1/2 the mass times the velocity of the object squared. Okay, so kinetic energy is equal, let's plug in the numbers that we know. 1/2, the mass of the race car was 1,500 kilograms, and its velocity was 80 meters per second. But we got to square that velocity. Always remember you have to square velocity in that case. So let me get my calculator and figure out what that is. 1/2 times 1,500 times 80 squared. And my calculator is telling me that it is, let me count the zeros here. So kinetic energy is equal to, let's see, so 4,800,000 excuse me, so 4,800,000, and that again is an energy value, so our unit is going to be joules. And so this race car, because it has a height of 0, will have a potential energy of 0. Kinetic energy, though, it has a lot of kinetic energy. It's moving very, very fast, and it does have a pretty high mass as well. And so you times that through, and you should get 4,800,000 joules. So hopefully that makes sense. That one had kinetic energy, but not potential energy. Let's go over one more practice problem. And this practice problem, number 3, says, using the diagram of the pendulum below, answer the following questions. Okay, we're going to answer A. It says, at what point is the potential energy, so potential energy, the highest? Potential energy, if you remember, potential energy is equal to mgh. The mass of this pendulum bob is going to be the same throughout, so and acceleration due to gravity is going to be the same throughout. And so we really want to find the spot where its height is the greatest. And it looks like to me the spot where it's going to be the greatest height-wise is going to be A and C. And so let me switch colors. It's not showing up that great with yellow. So A is going to be the spot where potential energy is the highest, and C, because it looks like it goes up to about the same height here, potential energy is going to be high at C as well. Okay, and so that's your answer for A, is point A and C. Now let's answer B. It says, at what point is the kinetic energy the highest? Kinetic energy, if you remember its formula, kinetic energy is equal to 1/2 mv squared. And so we're looking at the point on this pendulum where the velocity is going to be the highest. And as you, we talked about this in class a lot about a pendulum, but as you let the pendulum go at point A, that potential energy is going to be transferred. Let me go to a different color again, green. That potential energy is going to be transferred into a different type of energy. And so B has a height of 0. So all the potential energy is gone at point B. It is all transferred into kinetic energy. This is going to be the point where the velocity is going to be moving the fastest. So this pendulum will swing down and it's going to be moving the fastest at point B. And so that is our answer for B. And as it swings back up, that kinetic energy is going to be transferred back to kinetic energy. And so that it's really just using velocity here and transferring it to height and going back to potential energy at point C. And as this pendulum swings back and forth, you just see it transferring the energy from potential to kinetic to potential to kinetic. And That's how you answer problem number 3. All right, hopefully that makes sense. Let's go to the video physics assignment. I've got 5 questions for you that are going to follow. I want you to turn this in on a separate piece of paper, so you will turn it in for points. Again, I will scroll through them very slowly, but stick around for all 5. And as always, I wish you luck. If you do have troubles, come and talk to me and we can get it figured out. But hopefully that makes sense. Good luck.